Okay, so in this video, I'm going to talk you through how to create formulae from inverse proportion. And I'm just going to show you the process you want to go through in order to guarantee you pick up the marks in an exam. Again, it's very formulaic, very step-by-step, quite similar to how we deal with normal proportional relationships, direct proportion, and slightly more complicated other ones with a slight twist. Okay, so let's say we were given the fact that A is inversely proportional to B, and we were also told that pair of values when A is 6, B is 4. First thing I'm going to do is I'm going to follow the process to find an equation linking A and B, and then once I've done that, I can answer questions like this when you're given one variable and you need to get to the other one. So I'm going to work through A first of all down here. Okay, so when you're told that two values are inversely proportional, what you're being told is that one value is directly proportional to the reciprocal of the other. And by reciprocal, I mean flipped over, 1 over. So I can say, if I know they're inversely proportional, I can say that A is proportional to 1 over B. Okay? So you've got that proportionality symbol in there again. A is proportional to the reciprocal this time. Okay, so from that I can then say A is going to be equal to K times 1 over B, or K over B. And from here on in, it's not too bad. You're just going to put the pair of values in and then solve to find K, and that gives you your formula. So I know that A is 6 when B is 4. So 6 equals K divided by 4. If I times both sides by 4, 6 times 4 is my K value, which is 24. And that gives me the K value I need in this formula here. So A is equal to 24 over B. And if you prefer to, you can think of it as AB equals 24, but most of the time it's helpful to have one of the letters as the subject. Okay. I'm now going to use this formula to answer question B. So for B, I've asked find B when A is 12. So when A is 12, I can write 12 equals 24 over B. I expect a lot of you can see straight away what B is, but I'm going to go through the stages anyway for when we have tricky questions later on. Times both sides by B. 12B equals 24. Divide both sides by 12. B is 24 divided by 12, which is 2. Okay. Another little thing to mention on this before we move on, which is quite a nice way to check. If we think about our values of A and B, we started with A as 6 and B as 4. Then we had A as 12 and we've got B as 2. If you look at those values, hopefully you'll notice that as that one doubles, that one divides by 2. Okay, so one doubles, one halves, and we know that's the kind of pattern that we need to see when we're dealing with inverse proportion. Here's a slightly more complicated question. So this time, C is inversely proportional to F squared. And we've got, again, our pair of values. C is 5 when F is 3. I want you to find F when C is 2 and C when F is 1. If you feel confident with this, have a go at pausing the video, see if you can form the equation with all of the steps, and then use it to answer questions A and B. Okay, so I'm going to go through the process now. The first thing to notice is C is inversely proportional to F squared, not just F. So you need to pay really close attention, just like you did with some of the harder proportionality questions earlier in the topic, that you're noticing whether anything's happened to the second value. Okay, it's not just F, it's F squared. And they might write that in words, so it might be C is inversely proportional to the square of F. So keep your eye out for that as well. So I can say C is proportional to 1 over F squared. Don't lose that power. Okay. C is equal to K over F squared. And from here onwards, I can just put the two values in. 5 is equal to K over 3 squared, or K over 9. So 5 times 3 squared, or 9, is equal to K, which has to be 45. So now I've got my K value, I can write my formula. C equals 45 over F squared. Don't lose that squaring symbol. It's so easily done. Now I've got this formula, I can use it to answer A and B. So for part A, I'm going to find F when C is 2. So I'm going to substitute 2 in here. 2 equals 45 over F squared. Okay. And I'm going to times both sides by F squared. 2F squared equals 45. Divide both sides by 2. f squared equals 45 over 2. Now, because I'm going to need to square root, this is a brilliant time for us to start thinking about some surds coming in as well. So I can say f is equal to the square root of 45 over 2. Using our knowledge of surds, we know that the square root of a over b is the same as the square root of a over the square root of b. Feeling tempted now to start simplifying and rationalising denominators. So first of all, square root of 45 is the same as root 9 times root 5, because 9 times 5 makes you 45. Root 9 is 3, so I can write that as 3 root 5 over root 2. Still not going to stop yet because I've not got the denominator rational yet. So I can say 3 root 5 over root 2. To rationalise that denominator, I need to times top and bottom by root 2. Root 2 times root 2 is root 4, which is 2. 3 times root 5 times root 2. Well, root 5 times root 2 is root 10. So 3 times root 10 over 2, or 1.5 root 10s. Okay.